Hello everyone, this is the power of pi, and today we're going to be looking at the AMC 12B 2020 problem number 20. So two different cubes of the same size are to be painted, with the color of each face being chosen independently and at random to be either black or white. So what is the probability that after they are painted, the cubes can be rotated such that they are identical in appearance? So let's just do some casework, right? So what happens if we manage to paint both we managed to paint both the cubes all white? Well, then obviously we can rotate one to the other and make them so that they're identical in appearance. And the probability that both of them will be white will be 1/2 to the power 6 for one of them and then squared for the other. So now what about 5 white? Still, that singular black face, we can orient the two kind of cubes such that maybe the black face is facing towards us. So this will always be possible as well. There's going to be 6 choices for which to choose the black face, and then 1/2 to the power 6 squared. So now 4 white. So 4 white is probably where we get a little bit interesting because not always will we be able to orient it. So for example, if we look 1, 2, and then there's going to be something like that. So this is going to be the general view of the cube. So for example, if we choose kind of two opposite faces for one of the cubes, we'll have to choose two opposite faces for the other cube. Now both of them will be colored black. But if we choose two faces that share the same edge, we'll have to do that for the other cube as well. In other words, we can't choose one cube to be two opposite faces black and the other to be two adjacent faces black. So what's the probability that two opposite faces are black? Well, there are 3 pairs of opposite faces, and then 1/2 to the power 6 ways to color it to match that probability squared, or they can be adjacent. Rather than constructively counting adjacent, let's note that there's 6 choose 2 ways to choose 2 faces, and we know 3 of them are basically opposite faces, so that leaves 12 to be adjacent, and then again 1/2 to the power 6 cubed. Squared. So that's that. Now what about 3 white? If it's going to be 3 white, we can think of the 3 black. Now they're either opposite faces, and basically another face will be like bridging the gap. For example, say we choose this one and this one. This one will then kind of bridge the gap, or they can mutually share an edge. So those are 2 possible configurations. Again, let's calculate that probability. So for the first one, where we choose the opposite faces and then we choose one of the other 4 faces to kind of bridge. So there's 3 pairs of opposite faces and then 4 choices for that face that will like create that bridge. So 12 ways, 1/2 6 squared. And then again, what we'll do is we'll choose 3 ways to choose 3 faces, and then minus 12. This gives us how many of them mutually share an edge. So this is 8. So 8 times 1/6, 1/2 6 squared. And now 2 white, 1 white, 0 white. That's basically the exact same thing as 6 white, 5 white, 4 white. Black is now playing the role of white, and we know that both have a 1/2 chance of being colored, so we know it's symmetric. So what we have is 2 times 1/2 6 squared is 1 over 2 power 12. This one would be 36 over 2 power 12. This one would be, let's see, 9 plus 144 is 153 2 power 12. And then our 3 white is 1/2 2 power 12. So 144 plus 64 is 208, and then 2 power 12. So this is equal to, we can cancel out some stuff. So this is 190 over 2 power 11 plus 208 over 2 power 12. This is 380, 588 over 2 power 12. And 88 is divisible by 4, so I know I can cancel a 2 squared. So that'll give me 147 over 2 power 10, which is 1024, and my answer is D. So hope you guys enjoyed this nice probability question. Make sure to like, subscribe, and I'll see you in the next video.